Hello and welcome to section 6.2, exponential expressions with growth rates. So growth rates are going to be closely related to percentages. This is a really common thing in sort of everyday math when people talk about things increasing by a percent or decreasing by a percent. So to make a link between what we're doing in class and the way people do math in everyday life, we're going to be doing a lot of these word problems that are related to percents. So we're going to be using this everyday percentage terminology a lot. So let's do a review of it, where I'm going to start with an example to show you how to deal with these percents. And after you've seen these examples, you should be able to do these exercises on your own. So first of all, the word percent is basically Latin for divided by 100. In Spanish, I think the word is por ciento, if I'm not mistaken, which basically means by 100. And the English phrase of here frequently translates to multiplication or times. So when we say 20% of 500, we're talking about 20% times 500. So, and let's see, 20%, the percent thing, I'm just going to translate that as 20 divided by 100 multiplied by, so the percent here means divided by 100, and that means multiplied by 500. So to divide something by 100, you can just move the decimal place over 2 times. So if it was starting at over here, dividing it by 10, like 20 divided by 10 would be 2. Divided by 10 again, you'd move it over to be 0.2. So this is 0.20 times 500. And for that, you could multiply it with a calculator if you need to, or if you think you can do it in your head, getting the arithmetic practice is a good idea. But I know it's going to come out to be 100. Okay, so again, quick reminder, 20%, the decimal starts here, and it's getting moved over 2 places to turn it into a number to become 0.2. So 20% and 0.2 are the same number. Okay, so same deal here. The 2%, it really means 2 divided by 100. But to divide 2 by 100, we're going to think of taking that decimal place and moving it over 2 spots over here. So that's going to be 0.02. That's 2 divided by 100 times 500. So 2% is 0.02, and that multiplied by 500 is going to be 10. All right, now 120%, the decimal place is starting off right here, right after that 0. The percent means we're going to divide by 100, move that decimal place over 2 times. That's going to be 1.2. And if you want to write it as 1.20 to keep track of that 0, that's fine. Times 500. If you want to do this with a calculator, that's okay. But an important thing that we're going to need to understand this later is that this can be thought of as 1 plus 0.20 times 500. And you could distribute it. You could do the 500 times 1 and 500 times the 0.20. 500 times 1 is just 500. And then the 0.20, the other 20%, is going to be 20% of 500. So this is going to be 500 plus 100 is 600. So trying to think of it this way, where you split up something that's, if you take something that's more than 100 and you want to think of it as 1 or 100% plus however much over 100% it is, which is 1 plus 20%, and then add those up separately, you'll get the original 500, which is 100% of 500, plus 20% of 500 adds up to 600. So that's a good way to think about this. All right, so now it's your turn to do exercise 1 here. So let's pause it, and I'll show you the answers in a moment. Okay, so 115% of 1,000. I'm going to think of this as 1.15 times 1,000. And I want to do the 1 times 1,000 and also the 15% of 1,000 separately. And that's going to become 1,000 plus 150 is 1,150. Okay, 86% of 1,000. So the 86%, again, we're moving the decimal place over 2 spots to become 0.86. That multiplied by 1,000 is going to become 860. 200% of 1,000. So 200% as a decimal is 2.00 after you move that decimal place 2 to the left. And 2 times 1,000 is 2,000. Okay. Now I'm kind of giving this away. 1,000 times 1 plus 0.15. That's actually the same as the way I did it here. After you distribute the 1,000 in here, you'll get 1,000 times 1 plus 1,000 times 0.15. So that's going to be 1,000 plus 15% of 1,000 is 150, and that is 1,150. So the point I'm trying to make here is that A and D are the same thing. That you can think of 115% as 100% plus 15%. That will help you understand the concept that we're going to get to in a minute. Now, something else I want to point out is that 1 minus 0.14 here is the same thing as 0.86. So if you take 86% of 1,000, that's really the same thing that we're doing here. But I want to think of it as separated out into these two parts. Into the 1, which is 100% of 1,000, which is just 1,000, minus 1,000 times 0.14, which is 14% of 1,000. And 14% of 1,000 is 140. So if we take the original 1,000 minus the 14% of 1,000, what we end up is 160, which is 86% of 1,000. So both B and E are telling you the same thing, but written in different ways. Likewise here, we know that 1 plus 1 is definitely equal to 2. It's the same thing as 200%. But if we think of it as 1,000 times 1, that gets you 1,000, plus 1,000 times another 1. So we're thinking of like 100% of 1,000 plus another 100% of 1,000 gives you 2,000. So yeah, it's the same result. All right, now let's look at these things in a word problem sort of way. So the number of rabbits in a forest, which starts with 1,000 rabbits and then increases by 15%. So if it increases by 15%, you still have the original 1,000 rabbits. But then there's also going to be plus another 15% of 1,000 rabbits. So how is this going to work out? Well, 15% of 1,000 we can get by doing 1,000 plus 0.15 times 1,000, and that's going to be 150. So there's the original population of rabbits plus the 15% increase, leaves you with 1,150 rabbits. So this is the same thing as part A here and part D, and now we're just looking at it from a word problem sort of point of view. And being able to connect these three different ways of conceptualizing this is sort of what this section 6.2 is all about. Okay, now we have the price of a $1,000 bicycle that is on sale for 14% off. So the way you would calculate the new price is you would take the old price, which is 1,000, and then we're going to subtract 14% of 1,000. And the way to calculate 14% of 1,000 is move the decimal place over 2 spots. It was 14.0, now it's 0.14, and that gets multiplied by 1,000, so it's going to be 1,000 minus the discount, which is $140, and so the new price is $860. So again, that's the same idea as B and E. Now let's say we take the number of bacteria in a petri dish that starts with 1,000 bacteria and then doubles. So it's going to be 1,000, and if it doubles, you can write that as just multiplying by 2, or increasing by 1,000 more bacteria, and the result is 2,000. Okay, so yeah, again, C, F, and I are all looking at the same sort of thing, but with different ways of looking at it, different ways of calculating the same thing. All right, up next we'll look at a few examples, and we'll sort of tie all these concepts together in this box, which is going to be an important thing you'll need to memorize. So that will be in the next video.